get everything set up here real quick. Let's see, Google Colab, PyCharm, where are you? There we go, there's the PyCharm. All right, so I want to address this real quick. This is a quick pop-up live stream here to discuss the debug assignment for this week here. And the issue with it is that people didn't, or half of you guys did not change any of the code. You just downloaded the assignment and uploaded it right back up because you thought it worked. However, if you take in a phrase like, let's say, the phrase I was using was, bro, that is that surfboard is awesome. All right, and if I hit enter, it's including the word bro. That was caught correctly, is caught correctly, and then it was cutting off the last letter on awesome, which then made an even word, so then you'd have a misspelled word awesome on there. The point of the assignment was to take in a sentence and then print the words that are even. So if I'm looking at this, that is not an even number of words, and that is not an even word. That means the program does not work. That means it was not fixed, because this is the basic program that was downloaded by you guys on the website. So some of you guys just uploaded it right back up without changing anything. You just put your name on it and upload it back up. That means it's still broken, right? Because it doesn't output the right outputs. Some of you guys checked where if it was a period at the end, then you want to remove the last character. That's a step in the right direction, but that only removes periods. What about question marks or exclamation marks? And then that doesn't address commas and dashes and dollar signs and percent signs that are in the sentence. So therefore, nobody actually addressed the actual code, where it only prints out four or words that are even numbers, not necessarily four letters. Okay, here's another test sentence. Okay, we'll try this one in here real quick. Hey, Ron, the Royal Navy is looking for some koalas, robins, and deer. All right. Well, we got Ron again. Ron's only 3 letters, but it pulled in that comma. And we're missing, it looks like, robins. That is a even number word. That is 6 letters, but it has a comma on it, so therefore it thinks it's not good. Additionally, koalas is a even number word. It has 6 letters, but the comma makes it look like it's not good. So we're actually missing 2 words, and we have 1 additional word in here. That is not a working program. Using the default code, it is logically incorrect. All right. So looking at the same test sentence, let's look at a different kind of problem that uses similar type code, and we're going to work on it together. Right now I'm looking at PyCharm. We'll look at it in Google Colab in a second here. I shared the Google Colab link inside this stream as well, so anybody who's catching this later can also open up and see the Colab. All right, so if we look, we have our test sentence. Okay, we want to get an input. All right, we want to remove the last character. I went ahead and commented that out. All right, we need to clean up some code. Then we need to split it, and then we need to parse it. Now for this one here, what we want to do is we want the following word. We want any words that start with an R or a K. So instead of looking at the length, what we're going to do is we're going to look at words in the list. If the word from 0 to 1, the first letter dot lower equals R, or the first letter lowered is a K, so that could be a capital K or lowercase k, or a capital R or lowercase r, then we want to print the word. All right, let's jump over to Google Colab, and we'll see how we implemented it there. All right, hide PyCharm, bring up the Google Colab. All right, here we go. So, provided a set of code, find all the words in a sentence that start with an R or K, and that could be uppercase or lowercase. All right, we want to get the input from the user. Okay, that should look familiar. Here we want to remove the last character. We'll talk about that. We want to split the sentence up at the spaces using our split, and then display all the words that have an even number. Or, sorry, that have a start with an R or a K. Let's adjust. All words that start with an R or a K. All right. And then we want to, so we're going to print that out. And then we're going to go through our sentence list, find the words, as I just mentioned, from 0 to 1. That's going to find the first letter, make it lower, and compare it to the R, or compare it to the K. It's going to go ahead and print that word. Okay, so this is the sample code that's provided. It should look similar to the code for checking if a word is even or not. Okay, our test sentence. Hey, Ron, the Royal Navy's looking for some koalas, robins, and deer. Okay, we know that Navy, some, koalas, robins, and deer are all even words, so we should expect those in the solution, right? We should always know what to expect. That's how we can find out if there's a logic problem or not. Okay, so our task, we need to remove anything that is not a letter, and we need to only find the words that start with an R or a K. Okay, we have a couple different solutions we can do here. Let's go edit, clear all outputs. Okay, when removing anything not a letter, we could go by the aspect of, okay, let's remove all the periods, let's remove all the exclamations, question marks, commas, etc., etc. It just goes on and on. The list of items to remove could technically go on until every single non-letter character in the entire Unicode library has been removed. Hundreds of characters have been removed. That's not the most efficient way to go. So one solution I saw is if the sentence, and we want to look at the last index, just like 0 would be the first letter, 1 would be the first or the second letter, 2 would be the third letter. If we do -1, that's the last letter. -2 is second to last. -3 would be third from last. So you can go the reverse route through our string. So we're taking our string, and then if these items are in there, so if the period, exclamation, or question mark are in the last position, then we want to go ahead and take our sentence in, take the last position, remove it, and then set it inside our sentence in. All right. Let's see. Too many equal signs here. Okay, there. Now, hey, Ron, the Royal Navy's looking for some koalas, bears. Okay, let's go ahead and run that. And then we're going to go ahead and remove those items. And then we're going to go ahead and print it out and see what it looks like. So you can see there is the period on the end. We got some commas. And we got a comma. Okay. If we run it, hey, Ron, the Royal Navy's looking for some koalas, robins, deer. Okay, so we got rid of the last period. But what about all the commas? All those other items are still in there. So for anybody who used this, the end item or the item in, if you tried that way, that doesn't fix the problem. All right, that only removes the last punctuation. That means we're going to lose koalas and robins, and we're going to gain the word Ron into our list, which is not correct. Logically, that's not correct. All right. And if there's any dashes, question marks, dollar signs, any of those things in there, they are characters, right? And they will count towards that word or the letter count of the words, but they're not words themselves. All right, so this is a way. This is probably not the best way because it only removes the last item. I think some people even use the end with, okay, and it checks, does it end with a period? That only checks a single item, and it would remove it if it's true, and if it was false, it wouldn't remove it. Like as if the sentence didn't have a period on the end, then it wouldn't do anything. But if it had a question mark or exclamation, it still wouldn't do anything. It would only do it if there was a period. Okay. Solution number 2. On Wednesday this week, we talked about RE, which is the regular expression, which is often pronounced as regex, and it lets us remove a bunch of different characters with a single entry. Okay, and it looks something like this. You know, our sentence in becomes, we're going to use the regular expression, we're going to substitute, and anything within these brackets, so R stands for raw string, F would stand for formatted string, right? So R is for raw string. Anything inside these brackets is going to remove. So this looks like a left parenthesis, right parenthesis, a dash, and /s stands for a blank space. It's going to remove those, and it's going to replace it with just a space. And it's going to take anything inside sentence in, remove them, and then put it back inside sentence in. All right. Expand this out. So if we take the sentence, hey, Ron, the Royal Navy is looking for koalas, robins, and deer. We're going to import our regular expression module. And in this case, we want to move any parentheses, any dashes, any question marks, periods, exclamations, commas, and we're going to replace it with nothing. Just get rid of them, right? We're not worried about blank spaces, so I took out the /s out of here. All right, and then we're going to print it out. Well, let's go ahead and give that a run. If I run that, look, all the commas are gone, and it's just letters now. Now, the problem is that you have to manually tell it every single item that you want to substitute. All right, for solution 2, regular expression, you have to tell it which items you want to substitute. So in this case, we're not looking for dollar signs. We're not looking for percents. We're not looking for numbers like the actual number 5, not spelled out, but the actual number 5, number 10, float values. In this case, it'll take the period out of the float, and you're going to be left with 2 numbers. So 5.1 would become 51. We're not removing any numbers. And as we include more and more items in this regular expression for what we're trying to do, it's just going to grow and grow and grow until you have, 100 items inside the brackets here, the square brackets. And it worked for this small case, but that won't cover every case. And you don't know what the user is going to type inside their sentence, right? And regular expressions a little bit more on the complicated side if you're not familiar with it. We can do this better, and we can do it more simple. All right, so let's go down and look at solution number 2 or 3. Okay, solution number 3 is to parse our string. We looked at that on Wednesday, and you should have seen it in the videos where you look at each letter through a loop, right? You could say for letter in string, or in the sentence, or in our sentence in, it'll go through and look at each letter in there, and then we can decide. So we have the alpha character is what we're looking for. We're not looking for any numbers or special characters. We're looking for alphas, alphabetical characters, A through Z, capital or lowercase. And we can do that by having a string item or letter dot is alpha. And that's going to tell us true or false. If it's true, then we probably want to keep that. If it's false, ignore it. If it's a comma, that will be false. We don't want the comma. We're going to ignore it. Okay? So to implement this is alpha, we need to loop through our string. We need to check each letter as we're looping. Is it an alpha character? We probably also need to check, see, is it a space? Because we want to keep space as well. That way we can keep the words for our split. And then we want to make a new string, a clean string of just the alpha characters with their spaces between the words. That's it. Nothing else inside that new string. So to implement this, okay, let's go ahead and build this together. So this is the same set of code. I just have it broken up in individual blocks that we saw at the top of the program. All right, so we'll scroll all the way to the top. This bit of code right here looks very similar to the homework assignment, right? It's just broken down in individual blocks so we can take it step by step. So the first one, we want to take our, where's our crazy sentence here? Our test sentence. Okay, hey Ron, the Royal Navy, copy. Let's see, in this case, we are not going to take an input. We're just going to use a standard sentence. Okay, so I don't care. So sentence in equals, boom. And we're just going to set that as the actual value, right? In this case, I'm going to comment out this one. That way it's the same sentence every time, and I don't have to retype it every time, right? Okay, so run. Our sentence in is now equal to that string right there. Now, just like the registry regular expression, we were able to remove all the special characters. Well, if we're going to parse and we're only going to keep the alphabet characters, then why would we want to look at the last letter or last character? We don't need to. It's going to get removed if it's not an alphabetical character. And if it is an alphabetical character, then it's going to keep it. So we don't actually need this check here. All right? But what we do want to do is we want to clean our string. So first what we're going to have to do is for letter in sentence in, all right, if letter dot is alpha, I can't spell, alpha, if it's an alpha character, then we want to do something. If it's not an alpha character, ignore it, right? Okay, in this case, we don't want to print. Gotta love the autocorrect there. Let's go ahead and create a new clean string to store this in. All right, so we'll say clean string, or clean sentence. How's that sound? Equals empty. All right. If the letter is an alpha, I'm going to go with this for now, and then I'm going to show you why I'm missing something here and why it needs to get added in, okay? So if it's an alpha, clean sentence plus equals that letter. So we're taking the clean sentence. Every letter it checks, if it's a letter, it's going to add it to our clean sentence one at a time. We did this before in the first couple weeks, right? So it's going to check H. Is H a letter? Yes, add H to clean sentence. It's going to look at the E, the Y, the space. Space is not a letter. It's going to skip it. Look at the R, the O, the N. It's going to look at the comma. The comma's not a letter. It's not an alpha, so it's going to skip it. So in this case, clean sentence would be Heyron, right? And we can even do a print of our clean sentence just to see what it looks like. Okay, let's go ahead and run this one and see what it looks like. Our clean sentence, there we go. All the special characters have been taken out. But you can see now we can't tell which words are even and which ones are not. So we want to keep the spaces, right? We want to keep the space between hey, Ron, and the comma and the. So what we can do if the letter is alpha or letter is equal to a blank space, right? Right there's our blank space. Then we want to add it, which the blank space is a character. It's going to add that blank space character to our sentence. Let's go ahead and run it again. Let's see. Reset our sentence in and run it. There we go. This looks just like the registry, the regex version that we did earlier, right? Except we don't have to worry about which special characters are there. We're just picking out the alphabetical characters. That is it. We don't have to worry about did somebody sneak in a question mark or did somebody sneak in a $sign or a comma or a dash. It doesn't care. It only cares is it an alphabetical character. Okay, so solution 3 is looking pretty good. Now, since we have the spaces in there, we can now do our sentence split. In this case, we don't want to do sentence in split. We want to do our clean let's do it with the proper naming convention that the school wants us to use. We'll use capital S, capital S, capital S. There we go. Okay. So we use clean sentence, print clean sentence, print it one more time. Okay, yep, still looks good. Okay, down here we're going to split the clean sentence into our sentence list. And then what we're going to do is we're going to look at each word. So loop and look at each word in this list of sentences. If the first letter of the word, right, we're taking the slice of 0 to 1. So you could put 0 to 1. But in this case, if you leave it blank, it's going to automatically start at the beginning of the word. 0 to 1 because we don't include 1. So it's just going to look at 0, index 0. You could actually do that as well. Just do index 0. But in this case, we're slicing. So let's go ahead and slice. We're going to make it lowercase compared to the R. Take the also check, is the first letter lowercase equal to a K? If so, print the entire word, right? Let's go ahead and run. And we got Ron, Royal, koalas, and robins. Those look like all the R and K words in our sentence. So the biggest one, so if you guys want to find out if they're even numbers or not, display all words that start with a R or a K, right? If you want to look at the even ones, you need to clean it up. Get rid of all of those punctuations Then you can do your module and see if it's an even number or an odd number. If you're not sure how the module works, go back several weeks to the earlier videos we did, or the live streams that we did as well, or find the Google Colabs that I created for you guys, and that'll also tell you how to find out if it's even or odd, right? Everybody has until Wednesday, because not a single person actually got the assignment correct. Everybody has until Wednesday to try to get the assignment corrected for full credit. For anybody that did submit, you have until Wednesday to get for full credit. All right. This Google Colab is linked inside this video, and this video and the Google Colab link are also inside the Discord server. I will also send out an announcement in the school to check out this video. All right. Nobody logged in. I know I didn't advertise this one. This was a pop-up live stream that I just wanted to talk to you guys about parsing through strings. And if it says only print the even lettered words, that really means only print the even lettered words. That doesn't mean only print out if the words are perfect how you wrote them. You have to think, how might somebody else write their sentence? Is there going to be commas in there? Is there going to be different punctuations, dashes, question marks, percent signs? You know, I want everybody to get a 100% with the percent sign on this assignment. Well, if you did the assignment wrong, it's going to catch that percent. It's going to count it as a character for that word, which it should not. All right, so please, everybody, take another look at your assignment and clean it up. If you have problems, then contact me on the Discord and I'll help you guys. You know, this isn't a stump the dummy type problem. It literally, I mean, this is what, 4 lines of code, because this is extra. I don't even need this one right here, right? 4 lines of code was all that was needed, and you could take away the -1 here. 4 lines of code was all that was needed to make the assignment correct for this particular one, and this is pretty darn close to what it would look like for the other assignment as well. Okay, I can't directly give you the answers to assignments, but we can talk about similar type assignments, right? 4 lines of code, that's all it should take. All right, thanks everybody.